Inductors, storing magnetism. An inductor is formed by winding a coil of multiple turns of wire. The coil is most often wound around a cylindrical or donut-shaped form of a magnetic material. This is most often ferrite, a form of soft iron. The current through the wire produces a magnetic field in the core. The assembly becomes an electromagnet. This is a manifestation of Ampere's law. If the current is changed abruptly, an electromagnetic force, or EMF, is generated in the coil in accordance with Faraday's law. This EMF is always in opposition to the changing current in accordance with Lenz's law. What's the function of an inductor? When there is a current in an inductor, a magnetic field develops around it. Energy is stored in this magnetic field. An ideal inductor is characterized by a single constant value of inductance measured in henries. This is the ratio of the magnetic field intensity H to the current in the inductor. So inductance in henries is equal to magnetic field intensity divided by current in amperes. What determines inductance? Here I've put in an equation for inductance. L is equal to the square of the number of turns times mu, the magnetic permeability, times area, the cross-sectional area of the coil, divided by the length. Here the inductor is a solenoid where N is the number of turns. Just as the value of a capacitor in farads is directly proportional to its number of plates, the value of an inductor in henries is directly proportional to the number of turns of the coil. We can carry this analogy further by noting that just as the value of a capacitor in farads is directly proportional to the dielectric constant of the material between the plates, the value of an inductor in henries is directly proportional to the permeability of the material in the center of the coil. We also note that just as the value of a capacitor in farads is inversely proportional to the distance between its plates, the value of an inductor in henries is inversely proportional to the length of the coil. Finally, we note that the value of a capacitor is directly proportional to the area of the plates, and the value of the inductor is proportional to the cross-sectional area of the coils. Inductors are widely used in electronic circuits for blocking alternating current while allowing direct current to pass. They're used in filter networks for smoothing the output of power supplies and in resonance circuits that tune communications devices to particular frequencies. They're also used in electrical power transmission systems for stabilizing current and power flow.